Alrighty. So today what we're talking about is something called removable discontinuity. Okay? And what that means is that the graph is continuous. That part of the curve is continuous except at this one little point. Okay? So what we are going to call this is the fancy name, removable discontinuity. You need to have an idea what that is. Okay? But what we are going to call this is a hole. Is a hole in your graph. And what it looks like is for a section of the graph, things are going like normal. You're going to have a hole, and they're going to keep going. So the reason it's called a removable discontinuity is because if you were to fill in this hole, that section of the graph would be continuous. Okay? So these removable discontinuities, these holes, represent an undefined point on the graph. And these are created by factors canceling. So it's an undefined point on the graph created when factors cancel. A hole is always a ordered pair. It's a coordinate, it's a location on your graph. So in order to find that ordered pair x, y of your hole, first we're going to find the x, then we're going to use the x to find the y. To find the x, set the factor that canceled equal to 0. To find the y value, plug the x value into the simplified equation. Okay? So, something that's really, really important is that you must find holes first. You have to find holes before you start on any of the other Rady information. Otherwise, you're going to do a lot of work for the wrong answer, which is the worst combination. A lot of extra work for the wrong answer. All right, so in order to find our holes, we have to factor first. So start looking at number 1, x squared minus 3x minus 4 over x minus 4. How does that numerator cancel?
X minus 4 times x plus 1.
Okay. Oh, sorry, did I say cancel?
Yeah.
Sorry. How does the numerator factor? X minus 4 times x plus 1 over our denominator of x minus 4. Now, at this step, we see that there might be some terms that cancel. So the factor x minus 4 cancels with the factor x minus 4. And what am I left with? X plus 1. What kind of equation is x plus 1? A linear. So besides this hole that we've created by a factor that canceled, we're going to have a linear function. We have to find the location of that hole, though. So To find the location of your hole, take the factor that you canceled and set it equal to 0. So x minus 4 equals 0. What's the x value of our hole? 4. Then take your value for x and plug it into your simplified equation. Yeah, so y equals 4 plus 1, which is 5. So what are the coordinates of our hole? 4, 5. Okay, so at 4, 5, you put an open dot to represent the hole. Okay, then you can keep going with radii, but we already kind of know what this shape is going to be. What kind of graph is this going to be? Linear. What's the slope? 1. So couldn't we go ahead and just sketch in the graph? You don't really need radii in this case.
It's not always a movable function.
No, this is just so happened that it turned out linear. Make sure your hole is represented with an open circle. What is the domain of this function? What's the range of this function? Questions on that? Okay.
So in that situation, would you not need to do radii?
No,
Just linear.
you don't have to do the radii if you don't need it. Okay, y equals 5x minus 15 over x minus 3. Factor your numerator. And what happens? X minus 3 cancels, and we're left with 5. What does the graph y equals 5 look like? Yeah, our simplified version is just a horizontal line. But what is happening at one point? A hole. So let's find the location of that hole. How do I find the x value of that hole? X minus 3 equals 0, so x equals 3. Where do I plug this 3 back in? Yeah, to y equals 5, which means no matter what my x value is, what's my y value? 5. So where's your hole? So I have a hole at 3, 5, and then I have the horizontal line at y equals 5.
Could you have multiple holes?
Yes, you could have multiple holes. What's the domain? Negative infinity to 3, union 3 to infinity. What's the range? Yeah, you would just put a curly bracket and 5. All right, flip it over. So these are like special or trivial cases. Trivial in the sense that when you simplify them, they turn into other functions that we already know how to
If your
graph.
class has a lunch, please bring your cans down to room A204. Please bring only your rep and the alternate rep for your class. Thank you.
But if when you cancel stuff, you're left with a rational function, you are going to go ahead and use radii. Yeah. Okay, look at 3. What can we do on 3? Yeah, we've got x cubed over x, which we know simplifies to x squared. But I want you to think what we're doing. We are crossing off a factor of what? X. Okay? So we crossed off a factor of x, which means what has occurred?
X squared.
What occurs when we cancel things, though? A whole. We canceled a factor, so we've created a whole. So that whole is located at what x value? 0, because we canceled the factor x. We set x equal to 0. And then to get our y value, we plug in 0 to this simplified equation. What's that? 0. So what are the coordinates of our whole? X is 0 because the factor that we canceled was x, and you set the factor you cancel equal to 0. Okay. Now, what does the rest of this graph look like?
X squared.
Yeah, the quadratic parent function. Besides the whole at 0, 0, everything else looks the same. 1, 1, 2, 4, negative 2, 4, 1, 1.
So on a board tonight, what says rating and half, if it's a special case, we still need to.
If it's a special case like one of these first examples, it's okay to leave off the radi. Okay. Domain. Negative infinity is 0. Union 0 to infinity. And range. Good. Open parentheses, 0 to infinity. I just let y'all read it. Domain negative infinity to 0, union 0 to infinity. All right, let's look at number 4. What do we do first? Factor. So we have x plus 2 over what?
X minus 1, x plus 2.
X minus 1 and x plus 2. So what happens?
X plus 2 carries out.
Yeah, your x plus 2's cancel, and what are you left with?
1 over x minus 1.
1 over x minus 1. Okay? So this is our simplified equation that we're going to use. What happened when we canceled those terms?
We find a whole.
Yeah, we created a whole. So we need to go over here and find the information about our whole. How do I find the x value of my whole?
So we cancel factor equal to 0.
Good. So x plus 2 equals 0. So x equals negative 2. What do I do with that negative 2? Plug it into what? Good, the simplified equation, 1 over x minus 1. So y equals 1 over negative 2 minus 1, which is negative 1/3. So what's the ordered pair of my whole?
Negative 2 comma negative 1/3.
Good. Questions about that? Okay. Now let's go ahead and start filling out radi. What about roots?
Ready to use a simplified equation?
Yes, everything now is based off the simplified equation. So as we go through radi, you have to use the simplified equation. No roots because 1 does not equal 0, so we have no roots.
Oh, so you use all from the simplified equation?
I'm sorry?
You use all from the simplified equation?
Yes, everything is based off the simplified equation. Okay, asymptotes. X equals 1. T, check for any squared terms. None. E stands for end behavior, which is your horizontal asymptotes. So what do we have to look at? The degree. What's the degree of the numerator? 0. What's the degree of the denominator? 1. 0 over 1, that's low over high. 0 equals y. y. How do we do y? Plug in 0 for x. That's our y-intercept. So 1 over 0 minus 1 gives us negative 1. But we write it as a point. So what is that? 0 comma negative 1. All right, let's plot what we've got.
That's not true.
Where your hole is, you need to draw an open circle. An open circle to represent your hole. Now, your hole acts as kind of a point in the sense that it's going to guide how to draw your curve. The hole has to be a part of the curve. You can't have your curve down here and have your hole up here. Okay? It's got to be a part of your curve. So in that case, these are both on the same section of the vertical asymptote, so we are going to connect them. And then we can kind of use that to guide us. To the left, I have to be trending towards my asymptote. To the right, I'm going to have to go down. I can't go up because I can't cross the x-axis. Okay, this asymptote, which I forgot to label, bad me, does it split your graph or bring it together? Splits, because it's not being squared as its factor. So if I went down on the left, I have to go up on the right.
What would it look like if I brought it together? Would the top part just be flipped down across the y?
Huh?
Okay.
Okay, let's talk about our domain. You have to skip over your hole as well as your asymptote. So your domain is going to be negative infinity to what? Negative 2 union. Negative 2 to 1 union 1 to infinity. Everyone okay with that part? Okay, your range also has to skip over your hole and your asymptote. So what are we going to have? Negative infinity to negative 1/3 union. Negative 1/3 to 0 union 0 to infinity. I'm sorry? Okay, questions on this one? All right, look at number 5. So what are we supposed to do first? Factor. What do you notice on number 5, though? Yeah, you can't do the shortcut. You have to check and see if it factors a long way. So I take factors of 3 times negative 2, so I need factors of negative 6 that add up to what? Positive 1. So what should I use? 3 and negative 2. So I'm going to have 3x squared plus x minus, plus 3x minus 2x minus 2. Plot my 3x, I get x plus 1. Plot my minus 2, I get x plus 1. So I get 3x minus 2 times x plus 1. So why did I do that?
Because you can't do the shortcut.
Yeah, I have to factor it in order to get my simplified equation. So this is 3x minus 2 over x plus 1. All right, from here, I want you to continue, please. Find your hole. Are we going to have a hole?
Yes.
Yeah. Are you always going to have a hole?
No.
No. Just sometimes. Okay? I'm sorry? Find your hole and then find your rate information from your simplified equation.
Just this way?
We got 170 from this. So.
All right, so I want you to look up here and check your work.
Wait, whoa, why is that?
Why is that up so high? That second.
Is the curve be like low?
Okay, remember that these aren't like exact,
Okay.
okay? Like you guys need to calm down a little. This can be drawn in however you want to draw it in. It's just that it trends towards your asymptotes. Okay? Here, let me fix it for you.
Thanks, You're gonna get this all
Yay.
Goodness gracious. What is the domain?
Negative infinity, comma, negative 1, equal negative 30, comma 1. There is 1 other particle.
Okay, how about just look up here and get your domain, because we don't say that in unison very well. Range would be negative infinity to negative 1/5, union negative 1/5 to 0, union 0 to infinity. What's wrong?
Oh, I just read it wrong.
Okay. Other questions? Any questions about how this graph was created, about the rate information, any of that stuff? Okay, you have your revised homework assignment. Okay. I'm going to go ahead and stop this so that we can listen to announcements.